And 30 seconds to focus.
This is many fish.
On task, focused, high expectations. Study hall tomorrow, Thursday and Friday. You could check your desks real quick to make sure that they are on the tape and lined up.
Say with me, dale, ¿cuál
There's
es
just
lo que-
one side that has tape.
Ah,
Clarice, what's the main function of our bone? Movement. That's a good guess, but it's not movement. It's easy. Structure. So if we didn't have bones, we'd be a puddle. What is it? Structure. Cool. Salomon, the muscles. What's the main function of our muscles?
Like to move,
Movement. Cool. Matthias de los Rios, main function of our skin?
keeps all in place.
Keeps everything in place and protects it. Good.
What?
It keeps everything in place and it protects it.
Hold things
Holds it.
together.
Holds it together. What is the body's first response to injury? Inflammation. Martin Gallego, what do we use to see if we have a broken bone? Martin Gallego.
yes, I know.
Ah.
What do we see?
What do we use to see if we have a broken bone?
Inflammation. I
No,
know.
what do we see?
X-ray.
X-ray.
What?
X-ray.
because I didn't show
Look
that-
at learning goals. Talk about the circulatory system, blood, what it's made of. We probably won't have that break because we took the walk instead. Nervous system, coagulation, and mitosis. If we happen to get through points 3, 4, and 6 before 3 o'clock, then you can have another break. But
Cara.
if we can't, then I don't know if we can or not. If we can get through 3, 4, and 6 before 3 o'clock, then you can get another break. It's gonna be hard.
Media horita.
Then we'll elaborate, but the elaboration is going to be extended, and we're going to be drawing a diagram today. You have the mini thing, and then reflect on the learning goals. Learning goals today, again, it's all about circulatory system, nervous system, what our blood is made of. You should be able to tell all this stuff by the day. What is our response when we get hurt? All that good stuff. So pick a word or two to focus on. Similar to the last one, but there's some difference. Try to build upon it, right? We try to teach some and learn that and build upon it.
I recommend learning goals.
Just one or two words. Nothing too complicated. Okay, try to have your notebooks closed. Try not to follow along with writing things down. Try just to pay attention. And I will give you time to talk to each other about what we're talking about. And then later, I'll have all the most important words up, and then you're going to try and draw a diagram. So this is a little bit of a challenge.
Okay.
Okay? So we're going to think about our body like a city. This is New York City. New York City is slam-packed full of people, buildings, everything. So every little square is like a building. That's like our cells. We have cells everywhere. Hair cells, skin cells, bone cells, muscle cells, blood cells, cells. Okay? Every one of those apartments, houses, buildings is connected to each other by streets. Okay, and so our circulatory system, our nervous system, they're kind of like streets. Okay, they do different stuff, but we can think about it in this way to help it make understanding. So I'm going to go through quickly some models. I'm going to talk about some things. I'm going to draw it out. And again, just pay attention. We'll stop and talk about things. So the circulatory system, what is that called?
Circulatory system.
Amazing. It's made up of oxygen, which we call O2. That's just a scientific way to say oxygen instead of doing the whole thing. Oxygen is that gas that we breathe that keeps us alive. We have lungs, a heart, arteries, capillaries, carbon dioxide, that's CO2. Okay, carbon dioxide, it can be two, so there's two oxides. And then veins. Carbon dioxide for us is poisonous. Okay, it's not good for us. If we breathe it too much, if you were in a room full of carbon dioxide, you'd be dead.
But in the air is not carbon.
There is some, and what uses it? The plants. The plants make oxygen, and we're going to talk about all this stuff. Okay, all right. And our body produces carbon dioxide. It's our waste. It's our garbage.
Like when
Okay.
we breathe,
Yep.
you have to eat salt meat in salt mine in Bogota.
Twice.
Yes, there is inside carbon dioxide.
Well, yeah, because it's trapped, right? Because you're breathing so much. Yeah. So
But it's dangerous.
probably. I mean, if you hung out there too long, maybe. I don't know. I don't know. I don't think so. Like if you were like breathing in a bag, a paper bag, then you would start to get dizzy because you're just putting carbon dioxide into your body. Anyway, so we have oxygen coming in. The oxygen comes into our lungs. And then
But so like that.
it comes into our lungs, and then that oxygen goes into our heart, okay, in the form of blood cells, and then that blood cells, by blood
But the
cells,
lungs are
oxygen and
connected to
blood.
your heart.
Yeah, the blood goes from the oxygen to the heart. Yeah, you got blood, and it's all sorts of, there's whole systems. The system, okay, I didn't want to get into this too much. The air goes in and it's connected, and it goes into like some, I guess, connectors, what are they called? Areoles, that then have blood in it, and then that blood goes into your heart. So your lungs are here, and then your
Also-
heart's like there. Yeah, everything's connected. Okay, so that goes into your heart, and then it goes out of your heart and throughout your body in the arteries. So arteries take blood away. They both start with A. Arteries and away, they take blood away. Hey, say that.
Arteries and arteries.
Arteries take blood away. Great. So they take the oxygenated blood away. So blood away. And it goes to a capillary. Again, this stuff is all over your body. It's like chock full everywhere, everywhere, everywhere. You have blood cells, you have capillaries, everything that you can think of. So capillary's job do two things. Number one, it omits your oxygen. So this gives oxygen to your body. Your body needs oxygen to make energy. When your body makes energy, it produces a waste or garbage. And that garbage is CO2, and that goes into the capillary. So the capillary gives out oxygen, and then it takes in the carbon dioxide, and it puts it into blood, and then that blood goes back through your veins. What are those called? Veins. What was this part called again? That was the capillary. What's it called? Capillary. Cool. Capillary is really important. Anytime you cut yourself, more than likely you've cut a capillary. They're everywhere. Okay, like chock full everywhere. There's blood everywhere in your body. Your body needs to generate energy all the time. All right, all the time. So this is a complicated system that happens. Yes, sir, and then yes, sir.
Why did you do veins blue?
That's just what normally they do. Like arteries are red and veins are blue. I think it has something to do with the carbon dioxide. and
Veins
stuff, but
are blue. I think that
I mean, no, they're green. No, when you draw stuff, just normally, historically, red and blue. Matthias?
Like if you cut a very like
If you cut an artery, you'll know because it'll go. That's really bad news. If you cut an artery, like you're in big trouble.
Like more like that, like
That's right, yeah. Because at times with your heart pulses and then it shoots blood out, and then shoots more blood out. Like it's a big deal. And then vein, it just is like. But most of your cuts, most of your cuts are capillaries. Okay. The vein takes the blood back to your heart, back into your lungs, and then it comes out of your body as that CO2. Again, we breathe in oxygen, we breathe out carbon dioxide. Okay, that carbon dioxide is used by the trees, and the trees turn carbon dioxide into oxygen. It's a miracle. It's an incredible place. Our planet is incredible. You keep doing that, you'll get dizzy.
Maria.
Yeah.
Like this is like Maria.
Yeah, you'll because your body needs oxygen, and you're not providing oxygen to it.
And you cut that.
Too much of it, yeah, for sure.
Like how much time do you?
I'm not going to even tell you. I don't know. Let's say 1 second. Don't do it to yourself. Don't even try. Because if I say like 2 minutes and you go home, don't do that. Just don't try. you asphyxiate yourself. It's called asphyxiation. There's still gas in there, but it's carbon dioxide.
But why that happens? Like oxygen, why transforms?
Because that's our garbage. Our garbage is carbon dioxide. Our body uses oxygen, and then it changes that oxygen into carbon dioxide. Carbon dioxide? Does it need it? It's a good question. I don't know. Does it need it? Like if all carbon dioxide disappeared, what would happen? That's a good question. No idea. Good question. All right, cool. Talk to each other. What's the circulatory system? Explain it to each other. Turn talk. Let's go.
I know, I don't
Talk to
like.
Alejo about this.
I get dizzy. Oh my
Yeah,
god.
of course you did. Talk to Alejo about the circulatory system. For goodness sake. All right, 3, 2, 1, 0. When we breathe in, what do we breathe in, Dante? Oxygen. Emiliano, what do we breathe out? CO2. What gives out the oxygen and brings in the CO2, Alicia? What's the capillaries? Capillaries. What takes blood away from the heart, Miguel? Arteries. What gives it to the heart, Laura? What gives blood to the heart? There's a lot of Lauras in here. That's interesting. All right, cool. This is our blood. Our blood is here. Other animals' blood's all around it. Blood looks similar, has different pieces, has about the same parts. We're going to talk about 4 major parts or components of our blood. We have We have 4 different things. We have red blood cells, white blood cells, platelets, and plasma. What do we have?
Red blood cells, white blood cells, platelets.
We're going to try it one more time. We have red blood cells, white blood cells, platelets, and plasma. One way you can think about these things when it comes to a list is you make a really stupid thing and picture out of the letters. So I took RWPP and I said it's a really wide pregnant potato. So if you think in your head of a really wide pregnant potato, which doesn't make any sense, but it's kind of funny looking, you might have a chance to remember the 4 letters RWPP, which is red blood cells, white blood cells, platelets, and plasma. All right, cool. So let's talk about each one. We got red blood cells. 44% of our blood is made up of red. So if you cut yourself and you have some blood, 44% of that is red blood cells. It is there to bring us oxygen. That oxygen is energy. Okay, that oxygen is energy. The other 55%, so almost all of it. So 55 plus 44 is 99. So almost all plasma. So plasma. Sorry.
But what is plasma?
Plasma brings us the nutrients and takes away the waste. So plasma is this clear liquid. You can actually donate plasma and everything. But in our blood, if you were to take blood and like put it through a centrifugal thing, it'll separate it into all its different parts. So we have the red blood cells, which is red, and then you have plasma, which is clear. And the plasma takes the nutrients to everything. So whatever you eat, right, it gets digested, put in your blood, and then that blood, it sends it to all your organs and everything. Okay, whatever you ingest. So those of us that play with toxic stuff, it goes into your body, into the plasma, and then the plasma takes it to all of your organs. Yes?
I have a question. Like when you have a scab and it has blood, like why the blood turns like it starts red and then it starts.
We're gonna talk about that in a little bit, just not right now. All right, next up. Yeah.
Like if you put like music in your hands, it's like that, it's like of eating music.
Good question, probably. White blood cells, less than 1%. So there's not a lot unless you're sick because they fight infection. So white blood cells fight infection. And then we have platelets. Platelets are our friends when we get cut and we need a scab. They clot the blood. They're very sticky. So if you touch blood, it can be very sticky. If you get a cut, it starts to accumulate there, trying to sew everything up. It's almost like our tape. Yep.
I think that the blockades of the white blood cells are like they don't especially are in the veins or they are not that.
They're just in the blood.
No, they're in the blood.
But the blood is everywhere. No. But there's not a lot of blood outside of our circulatory system because our circulatory system is everywhere. It's hard to imagine, but like you're chock full of capillaries. You have so many capillaries, it's not even funny.
Why we call and you don't grab a vein while you suck that?
We're going to talk because you cut capillaries. Capillaries attach your arteries and your veins. And the capillaries are in charge of a lot of stuff. We just have tons of stuff. I actually asked this question today because I was like, what happens though? Because if you cut yourself, you're not cutting a vein or an artery. What are you cutting? And most likely you're cutting a capillary. That's how many capillaries we have. They're just everywhere.
Because always that I cut.
Okay.
Tenemos 18 minutos.
No. Capillaries. So you're not going to cut. You're almost never going to cut a vein or an artery. Almost never. Unless it goes very deep. You are cutting capillaries. Yes. No, it's Laura and then Matthias.
Like when blood dries, it's not why it has like that weird consistency.
It gets sticky because of platelets. Matthias.
So when like you cut the capillaries are like those of an artery or a vein.
The capillaries are the things that kind of connect everything together, but you're not disrupting the vein. I think that there's probably more capillaries that kind of go off and like branch off and kind of suck things. I'm not sure. It's hard to understand like just how many we have and where they all are because I'm confused too. Yes.
Like when they put you a tuna, you can lose your if they don't do it carefully, they can like damage your vein.
I mean, if they don't know what they're doing, that's why we put it here though, or in the rear end because it's not a lot of veins there.
But
In your
sometimes
butt.
when there is a carsa, you
A lot of times they stick you right in the butt because then there's not a lot of stuff. What's that? That's when they usually take blood out, right into your vein. It goes into like your blood cells, it goes into your muscle cells. I mean, and then it goes throughout the body, and that's a great question that we can answer later. It's supposed to go. Actually, I think some are supposed to stay in your shoulder and then activate your immune system, and then they defeat it. So then they know how to defeat it later. I think others travel throughout your body, but I think it's supposed to stay in your shoulder. I think. Oh, where was I? All right, cool. All right, now we got the nervous system. Oh wait, sorry. Talk to each other. What are the 4 parts of the blood, and what do they do? Talk.
Red blood cells, white blood cells, plasma. I don't remember.
Really wide, pregnant potato.
Red, white, plasma. Platelets.
All right, 3, 2, 1, 0. We have a really good. Okay. To add to your, they don't really make plasma TVs anymore, do they? No. So if you remember plasma, but you're having trouble thinking about platelets, you could add a plate to the potato, a plata. If they're really wide, pregnant potato could also be holding a plate, and then you can remember platelets. Just a thought. All right, cool. All right, so we have our nervous system. Our nervous system is made up of 3 items: the brain, the spinal cord, and the nerves. So spinal cord, very important. It's protected by our spine. You break your spine, you have really bad problems. Nerves, just like everything else, is everywhere. Nerves are everywhere. Any part of your body that you touch and you have experience, that's a nerve there. And the brain and the nervous system talk to each other. Okay, I do want to try and finish. I do. Just hold on. Just hold on. And then and I also want to answer questions. Where was I? Okay, so brain, nervous system. They talk to each other. Nerves send signals to the brain, and then the brain responds back. Okay, depending on what's going to happen. So how can we connect all of these things together? When we get hurt, the nerve sends a message to the brain, normally pain, right? You get a cut somewhere, you feel that pain. The brain says, oh, we have a problem, and it sends the message back to through the nervous system to the nerve to start sending more blood there. Why do we need more blood? We need more blood because of the platelets. The number one thing they want to do is they want to stop bleeding. Your body wants the blood to stop. That's why it gets sticky. Okay, it gets sticky because of all the platelets that are gathering up there trying to stop the blood bleeding because they want this to happen, not
We have
that.
an existential dude.
I'm looking this up.
We have a breakthrough.
It
Hold
is
on.
big.
It's really big.
Watch.
Oh, gas.
This is a cell. It's a blood cell. Or no, not blood cell. Probably. I can't.
What does it have an increase like mini sun?
That's what's going on in ours too.
There is bacteria.
It's a cell. I don't know what kind of cell.
No, it's okay. It's okay.
All right.
It's divided.
It divides.
Cool. Let's see that again.
No dos bacterias, es que se está dividiendo para.
Silencio, por favor.
It's probably could be a skin cell, could be a muscle cell, bone cell.
But how they see that? That's like so.
Microscope. And so this one cell turns into two cells. This is called
Ahí se están conectando.
mitosis. What is it called?
Mitosis.
One more time.
Mitosis.
Mitosis. So mitosis. Why are we
So we
throwing
can
something
have
at Lolo?
infinite.
A bunch of people are throwing things at Lolo. What's going on? Is this a Real Madrid thing? Are we celebrating something?
Yeah, no, we're looking like the result. The score.
Did they score?
No, we
want to see
know.
how many. We can final del primer tiempo. Ya se dividió el primer tiempo.
I think we're gonna get through and be able to take a break because then you can look at the score.
Sigamos, Ray.
Mr. Light.
Move on.
Hold on a second. So then we have mitosis. Why is mitosis important? Because if you have a cut and you've damaged your skin or your muscles or whatever, it needs to regrow. So once it stops bleeding, then your body goes to work and all of your cells start to go through mitosis, making more and more and more cells so that you are healed. Our body is a miracle. Yes, sir?
That's so that the mitosis is happening all the time, only that is accelerated in the times when you are
Yes.
growing and when there's
In about 1 month, your whole body is new cells. In about a month.
Oh my God.
Okay? Yeah. Like we're losing skin cells all the time. New ones are being regenerated. It's happening all the time. That's why the Japanese say every breath is a new you.
Salomon, I have
Yeah.
that biggest question of life.
Go for it.
There is a theory that you never touch. Like, no
Ah,
one.
yeah.
So when you cut, how you are cutting
You
the
know, it's too much. It could just be, what is it, a simulation in our brain?
Pero yo si me
whatever?
toco y me duele. Si yo me toco me duele.
All right. Talk to each other about the nervous system and the response to energy. Go. All right, 3, 2, we can do this. We almost got this. 2, 1, 0. Okay, because then it would be, let me just make sure my math is right. Okay, awesome. Why do we need blood everywhere?
for I think for yes, energy. I know.
Right, we need energy, right? Every part of our body needs energy. Okay, we need to have healing, right? Any place you get cut, you need blood there to stop it. Yes, sir.
And the blood has oxygen.
Blood has oxygen. That's what helps us with energy. What would happen if we had an interruption in our nervous system? Let's say you broke your spine and your brain could not communicate to your legs. What would happen? Lord.
I think they would
fall,
What can happen, like he said,
Why? Why would you fall?
because like your body, like your body's not working and your face is showing like blood. Like
Kind of, what can your brain not communicate with?
You don't have
with
equilibrio.
your, for example, with your hand or with your
Right, so if there's an interruption in your communication system and your brain can't communicate with your muscles, then you can't move. If you get cut and it can't report to the brain, then you're not going to feel it. Right? So there's a big problems with being paralyzed because your nervous system is what communicates. And if you have a break in your nervous system and you cannot walk, you have no feeling in your legs. So if you get cut, your body does not know that you're cut.
So basically, you don't feel pain.
In the lower extent, no. And there's some people in the world that do not feel pain. It's very dangerous. Very dangerous because they don't know when they're hurt. They don't know when to push. All right, at this point, somehow, I guess because of my excellent
that happened to
teaching.
persons where recientemente they thought that
Take your 7, go.
that happened to persons like basically like they thought like of I think like
Spinal cord is like a cable, and so it gets snapped.
El Inter va ganando. ¿Cuánto? 0. ¿En dónde? En Múnich. En Milán, no. Sánchez. Múnich, ¿qué vamos? ¿Cuánto va ganando? Cuando te vi. Cuando el Inter. Cuando te vi. Cuando te vi. Lo que diga,
Ahí se comió toda. Déjame tocar antes de dejar.
¡No está vacío!
Está vacío. Estamos con 3 papitas. Yo lo vi cogerse de morro. Lo vi cogerse pero morro. Cuando vos entraste, no, cuando vos entraste.
Yo no sé. Y antes ya había una línea por acá de papitas.
Ya no salta. Pequeño canguro.
Ya lo tira arriba, no.
¡My computer!
Y tú me robaste papitas.
bueno, voy tomando prestado.
Por cierto, voy entregando mi lapicero ya.
¿Cuál lapicero?
Bueno, te hagas el bobo. Bueno, no me hagas ahí. Ya, cerrá. Oye, huevón, ya. Marica, ya. No, ten. ¡No! Me robaste papita.
Ay, papá. Salimos ganando.
¿Qué hacen?
Este marica y este marica me roba.
Madre lo robó papitas.
Me robó papitas. Ya me queda nada. No, mal. ¿Dónde lo guardas?
Pequeño canguro.
Toma.
Toma.
yo esa no la detesto. Tú no te imaginas cuánto. O sea, es que ni te alcanza de imaginar. Ni te alcanza de imaginar. Ni te alcanzas. Doce 57. ¿Por qué? Porque no podíamos salir a las 3 y a las 3 y me pasó 3 veces.
Que son, no sé, cosas raras, porque cuando fui ahí, me que me estaban hablando de cosas que son ellos, yo no, dijeron que estaban hablando de monkeys, seguro que estaban hablando de Hamburg.
Pero llegué y estaba por ahí.
Like the same thing. All the times I tell you that the like they concern like the thinking of the why they why we have one type of like P or B cells for everything. There's also for our own cells. So that organ not only produces, also kills the one that are of our own cells, you know, and the bad ones and things like that. You know how many percent they are killed? 98, 98,
Pretty good. So I guess the ones that survive are
2%. Only 2%. No, like they're not equally strong. Everything. Maybe they're 11% of the population, but like if they're like bad,
No, I'll answer your
like
question.
bad working or they are like very happy with what
Come and study hall here and talk about like and then you can retest something. That's what you can do.
I probably tried there.
Gallego!
10 minutes, diagrams. So diagrams don't necessarily have movements. Unlike Lolo's computer. Lolo's computer moves, see, and it moved and it shut down. That was a movement. Excellent. And then it's going to be closed. And so your challenge right now is to create a diagram using as many of those terms as possible. Let's go. A diagram is like a model without, it's like the model is supposed to be you paper diagram. It's not movement. There's no movement. You don't have movement.
But can we like what we want? Like
So a diagram, what do you think you should draw? The human body. And then the human body contains all of this stuff. So your job is to create a diagram of the human body. It's like a model, but without any movement. You can show movement if you want.
like how do I say costillas?
Ribs. Ribs. O2. I use the whole thing. You want to see the body I made earlier?
Yes.
Simone's gonna feel better about himself after this.
No son las arterias. Son una línea.
Son amigos. ¿Pero las pictures? Las pictures. No soy capaz de hacerlo bien. ¿Me llegan las pictures? Es que no me vas a hacerlo bien por mí. ¿Me llegan las
Ustedes ya se lo han hecho en pizzas.
I like finished this drawing and I'm like, we just had a break. Do the work. You need to make a diagram that has every single one of those words in there. Labels.
Every single one.
That, I mean, you got 8 minutes to try. Switching on after a stroll and a break. That's why we do these things.
How is the part when beans and like the part you said that it's here when we
Opa, es que todo está allá en YouTube.
the part when beans
Está poniendo todo ahí.
El mío parece un mamarracho porque nada más tiene un poco de nombre. Bueno, ahorita las arterias. Tengo una gana de no, yo lo que quiero mostrar es que
Cuando llegan los
This thing, I don't know. It's probably science. Because I don't know. Anyone tells you they're sure of it? But when I am sure, really wise, pregnant, and like, white blood cell size, you got 5 minutes?
no. Antes de que me empezara tu mamá y se la
prefiero esa otra cosa que
qué puta. Pero es que
Missing a
¿qué
lot.
voz? Uy, qué niño tan
Getting there.
Ya llegaron los.
Let's go. Try.
where is the white?
El sistema nervioso está por todo el cuerpo.
My coach is one capillaries. They connect the veins.
Ya llegaron los.
Yashas will be bringing the front.
Ah, no, mañana fue jueves.
All those words.
Can you check it? I can follow.
It's got a lot of stuff going on.
That's all of them.
It's not all of them.
No, all.
I don't see platelets.
Gentlemen, nobody has all the words there. Nobody. Good Lord. All right, sitting down. 3, 2. I'm going to tell you some stuff.
Very bad.
1, 0. All right. Now, apparently there are 25 trillion red blood cells in our body. 25 trillion. 5 trillion. That's a lot. They are replaced at 2 million cells per second.
What?
So I don't even understand that. Apparently we get 2 million Just hold on a second. Our brain communicates with the system and back at 120 meters per second. So that's how fast the signals go, about 120 meters per second.
So that's like from here to here, like.
That's why it's like you feel it, right? Because that's 120 meters per second. Does that make sense? Now, you had said, Simone said something about the nervous system, but then it's saying like it's 600 miles, like 965 kilometers. But see, I heard something like that too. But we have a ton of nerves, so if you took out all of our nerves and lined them up, it's at least from Bogota and back, but it could be much longer than that. That's how many nerves we have. Twice. Yeah, I don't know. 10 capillaries are the size of the human hair. Same width. The width. So if you take out hair, the width of the hair, that's 10 capillaries. So capillaries are super
you want for let your hair grow for 2 months? I want to see you like with longer like.
I don't want to see it. Check your desk, make sure it's okay. And pick.
Oh, happy face. Oh, my fault.
You can try that. Pick your level of difficulty. I got some new stuff. I'll take care of it later. And here we go. What are the main components of blood? Really wide, pregnant potato carrying a plate. No, you gotta write out the words.
I'm gonna put red blood CV, okay? No, red CV, BC. O sea, red blood cells.
And then like fill out the words next to it.
I am so good at this. I already have the first.
I mean, you can write whatever you want. It just would be wrong. Red blood cells, white blood cells, platelets, and platelets and plasma. Why is it important for blood to reach all parts of the body? All parts need energy. All parts need help. All that good stuff.
Oxygen.
Oxygen.
Give energy and
How do nerves help the body respond to energy?
Sorry.
Vamos a ver. Yo con un 3.5 me voy a feliz. 3.25. Bien, se redondea.
Psicópatas. Sí, porque
It lets us know. It lets the body know that there's an injury. Why does the body send a lot of blood to an injury site? It tells us when we're hurt.
What?
The nervous system tells us when we're hurt. I should say, like for a cut, I should probably change what the injury site is. So I'm talking about when you get cut.
When you get a
You get a cut. It sends all that blood there to stop the bleeding. Strange, right? Sending all that blood to stop
How we
bleeding.
contact
because
with the blood vessel?
La ley no
of
tragará.
platelets. And again, like we don't have that many platelets in our blood, so it needs to send a bunch so that we have a lot of platelets. Once the bleeding stops, what happens next? So what does our body do? How does it start repair? Number 4. To stop bleeding. Starts with an M, it rhymes with mitosis. Mitosis.
Bye-bye.
You can put the chairs up and you can
Goma, goma.
Oh no.